does the sequence an n to the fourth over n cubed minus 3n converge or diverge?
Is what we just like do like make a little graph like a X and Y chart and then just look at it? Or?
Yeah, you can do, we've looked at limits in lots of ways, right? So you have options in what you do. So we'll just take a couple minutes and I'll let you work on that one. If you have absolutely no idea, maybe look back at the notes from last time. Ask someone sitting next to you if you're really stuck. The notes from Monday, we calculated some. And then we did some, I think, on Friday as well. But I know we did some Monday.
do all of them go.
Well, it takes a long time because I have to, because I post them online, the videos can't be too long, otherwise it would take me like an hour to upload one video. So I have to cut them into pieces, which means I have to listen to them and figure out how to cut them up, so that all takes time. Ideally, once I get comfortable with doing this, so maybe like starting next week, I can start posting the videos daily after class, because I'll know the process and how to do it.
Wouldn't it be easier to like share it with Google Drive?
But even to put it on Google Drive,
It's
it
not
would
gonna be on
take,
YouTube.
because anytime you upload that big of a file, it'll take forever. Yep.
I looked at
Usually trying to fix problems based on what's yeah, we've kind of left intervals for a little bit, and we just want to know about the limit. Okay, have you convinced yourself one way or the other yet? It does not converge. Alright, is everyone else convinced of that? Yes?
I don't know, it's working.
Yeah, we can do it. I just want to give you an opportunity to think about it before I show you how to do it, because you've got to do these on your own. So what you're trying to do is calculate this limit. Does someone want to tell me one way that they could calculate this limit? Yeah, you're telling me to use L'Hopital's rule, right?
Change it to a function.
Yeah. Yeah. When you do limits and you talk about derivatives, usually you're talking about L'Hopital's rule. And if I look at this limit, the numerator n to the fourth, it goes to infinity. The denominator also goes to infinity because the n cubed is going to get larger than the 3n faster. So you could switch it into a function if you want. X cubed minus 3x, and then use L'Hopital's rule, which gives me the limit of what? What's my numerator now going to be? 4x cubed, the denominator. 3x squared minus 3. Okay. Oop. So I'm looking at the limit now. I still get infinity for the numerator. I still get infinity for the denominator.
Do it again.
Do it again. The limit as x goes to infinity. What's the derivative of the top?
12x.
Okay, and the bottom? You could do it one more time, or you could go ahead and simplify that. What does it simplify to?
12x over
2x. And I'm looking at the limit as x goes to infinity. What's that limit going to be? 2x. Infinity. Right? So what's my answer? Converges? Diverges? Diverges. Okay? This isn't the only way you can do this, though. There are multiple ways to do some of these problems, and so another thing you could have done, this is the limit, right? We were looking at n cubed into the fourth over n cubed minus 3n. Remember that this is essentially like a rational function. I have a polynomial of n divided by a polynomial of n. So we compared degrees previously. What was the degree of the numerator? 4. The degree of the denominator? 3. And then remember I took the larger of those values. And you can multiply by 1 over n to the fourth 1 over n to the fourth. Yep. And then you distribute. So you'll get 1 in the numerator. You'll get 1 over n minus 3 over n cubed when you distribute. And look at what happens now. The numerator is 1. Look at each piece in the denominator. What's the limit of 1 over n? 0. 3 over n cubed? 0 minus 0 is 0. So I have 1 over 0, which tells me it's either infinity or negative infinity, but these are all positive terms because n is positive, and so in the end, in the end, this is going to be infinity.
So that's just another way to solve that.
Yeah, it's just another way. All I'm telling you is, and there's probably other ways that I'm not mentioning here. You can use whatever as long as it's mathematically sound in what you're doing. Okay?